Okay, here's another equation which we're going to solve, another quadratic equation which we're going to solve by the difference of two squares. Now, with any quadratic equation, one thing we always should be doing is, for quadratic equations, that's the x squared type, or in this case a squared. Okay, so x squared is what gives it away. Any equation with an x squared and is a quadratic. In this case, the variable is a instead of x. What we have to do always is move everything to the left before we begin. Okay. So what we're going to do here, we're going to move this 25a squared across. Okay, we're going to move 25a squared across to the left hand side. And that's going to give us 9. When the 25 comes across, it's going to become minus 25a squared is equal to 0. And now we have a difference of two squares. We have a difference means subtraction of two squares. 9 is a perfect square, 25a squared is a perfect square. So write them as such. So 9 is 3 squared minus 25a squared. We would write that as 5a and then square all of it equals 0. So now we've got our familiar first squared minus the second squared. Okay, the pattern, remember, is the first minus the second, so 3 minus 5a times the first plus the second, 3 plus 5a. And put that equal to 0. And now again, when you've got a product and the product is equal to 0, then each of the individual factors, one or both of them, had to be equal to 0. So we have 3 minus 5a equals 0, and 3 plus 5a equals 0. Now this, you can only say this when you have the product equal to 0. And that's why we move everything to the left before we begin, because this needs to be equal to 0 for this step to work. If we have something like this equal to 5, or equal to 7, or equal to negative 42, it doesn't work. It only works if we have 0 on the right hand side. That's why we move everything to the left before we begin. Okay, so we've taken it this far. And now what we want to do is get the letter on its own. So we can see what's on the wrong side, and in either of these we can move the negative 5a across. We can do it that way. And if you do it that way, you get 3 is equal to, if we move the negative 5a across, we change the sign, becomes plus 5a. And then you always divide by the number attached to your variable. So divide by 5. Okay, you see people trying to do different things here. You see people trying to divide by 3 because it's on the left. You see people trying to divide by 3 because it's smaller. But what you should be doing, and the only thing you should be seeing, is people dividing by 5 because 5 is attached to the a. So divide by the number that's attached to the letter. So it's going to be 3/5 equals 5a over 5. These 5's cancel, and therefore you have 3 over 5 is equal to a. Over here, you want something similar. This time I can move the 3 across, and it doesn't really matter which one you move across, but for me it depends on minus signs and the convenience of minus signs. So if we move the 3 across, we're going to be left with 5a. If you move the 3 across, it changes sign, so it becomes minus 3. And then again, we're going to divide by 5. Divide by the number that is attached to the variable. So it's going to be minus 3 divided by 5. The 5's will cancel. So we have a is equal to a minus over a plus is a minus. And it's just going to be 3 over 5. You can't reduce that. You can't simplify it. You could write it as a decimal as you want, but why go to that extra step? Negative 3/5 and 3/5. Okay, that's our whole chapter on difference of two squares, and I hope you have found it okay, and that you'll practice it and review it before any tests and quizzes and exams, which are a little bit off in the distance. But good luck. Thank you for watching.